Hello students, welcome back to our discussion of Chapter 5, Normal Distribution. Slide 7 gives you a really good example of a question that we'll be doing a lot in the booklet plus on the exam. So this is a typical question. This question is actually on page 62, and we're going to be doing a series of questions similar to this. So it states that IQ, or intelligent quotient, is assumed to be normally distributed with a mean of 100 and standard deviation of 15. The question states, what is the probability that a randomly selected individual will have an IQ greater than 125? So there's a few key things in here that we need to pay attention to for normal distribution. We know that it gives us an average, listed there is 100, gives us a standard deviation of 15, and this value of 125 is the x value. Other key parts in this question is it's going to say words like this: greater than, more, increase, decrease, less than. This tells us something important about the probability. Remember that normal distribution calculates continuous probability, so we need to in normal distribution we will be calculating if it's more than or less than or between certain outside values. So those are the key things we need for normal distribution: the average and the standard deviation, and then an x value. This is the three-step process. Instead of going through this in more detail, I'm just going to go into how to actually calculate normal distribution. It refers back to finding the three-step process where we calculate a z, we find an area or probability number using table on page reference table on page 126 of your course outline or of your course package, plus then the final step is to adjust the various probabilities. So the first thing we want to do is calculate a z value. We're going to calculate that z value using this formula here: z equals x minus the average divided by the standard deviation. Oops. So let's go erase this and calculate a z value. Step 1 is to calculate a z value. Where are we here? Z. Z equals x minus the average divided by the standard deviation. So x equals 125, the average is 100, standard deviation is 15. This gives us a positive z value of 1.67. We round and keep our z values to 2 decimal places. So this is step 1. Step 2 is to find an area that corresponds to that z value of 1.67. So what we do here is we go to page 126 in your course package. I have it listed here. This is Appendix B, normal distribution table. You will be using this table extensively for this unit, or for this chapter, and for the next unit as well. Just give you a little idea, a breakdown how to use this reference table. There's z numbers going down the left margin, left side, and z values going across. The values going down are to 1 decimal place, and the values going across gives us 1 more decimal place. So that's why, for our purposes, z values are going to be limited to 2 decimal places. So a z value of 1.67, we find it here. There's 1.6, and in the column of 0.07, we're going to find where they intersect, and we get an area value of 4525. 0.4525 corresponds to a z value of 1.67. Let's go back there. So here we know the area equals 0.4525. Now what I highly recommend in order to find the third step, find the answer, is we draw out this normal distribution. So draw something like that, perhaps a little better than what I'm able to draw on this device. We know the average equals 100. I'm just going to put this number up here, standard deviation equals 15. And I'm going to change colors here. And the x value is 125. Well, this is a continuous distribution, so values down here are low, values up here on the right side are higher. I'm going to put the value of 125 right there. So there's x equals 125. The question, the original question, we can go back to that, asks us to calculate the probability that a randomly selected individual will have an IQ greater than 125. That is a keyword we need to determine what area we actually shade in. So I'm going to change this color again. Basically it says greater than 125, so we want all of this area here. We want to know the probability that someone, randomly selected individual, has an IQ in this shaded in area. If we go back to the normal distribution table, Appendix B, we get an area of 0.4525, and then on this little chart here we have the middle value and we have the Z value. This Z value here will be 1.67. The numbers we get in the interior part of this table always correspond or always match from the middle out to the actual Z value. So that's what we can draw here. 4525 is this interior section, always from the middle outwards. So it is this area here, 4525. We don't want to know that middle area. We want to know the final answer, which corresponds to the section that we have shaded in. We know from our discussion of normal distribution that half the average is the median, and it corresponds to half of the area. So the whole area on the right side of the average of 100 is 0.5. The section we know is that's not shaded in is 4525, and we are left wanting to know this area here. So our answer is going to be simply taking the difference. 0.5 minus 4525 gives us an answer of 0.0475. Or if we want, we can convert that to a decimal. There's a 4.75% chance of randomly selecting an individual from the normal distributed population and his or her IQ being at least 125 or greater than 125 is 4.75. So that's how we would answer this question as we've drawn here. So calculate Z, three-step process. Step 1, calculate Z using that formula, find the area, and then adjust your answer, your step 2 answer, depending on how you draw out the bell curve. Always recommend drawing out the bell curve. So there are some other questions we can go over. We'll go over a few of these in this section, in this video, and then we'll finish up the rest in the other videos here. So this, these questions here are on page 63, I should say, 63 and 64 of your course package. We did question 1A. Let's take a look at question 1B, where it says we want to calculate the probability that a randomly selected individual has an IQ less than 80. So we'll go back to this drawing board. Let's erase it, and let's put in here what we're looking for. Basically, the probability that the individual has an IQ less than 80. Step 1 is to calculate a Z value. Z is 80 minus the average divided by the standard deviation. So this question just builds on the information in question 1, where the general population has an IQ average of 100 with a standard deviation of 15. So this Z value is going to be negative. Negative 1.33. Negative means that they are on the left side of the distribution, that they are less than average, and we can tell that from looking at our score as well. 80 is less than 100. Step 2 is to find an area that corresponds to this Z value of 1.33. When you are finding an area, it does not matter if Z is negative or positive. So 1.33, here is 1.3, and there is 0.03. So this area is 4082, 0.4082. That's the area that corresponds to this Z value. So once again, a negative Z value just means it's on the left side. A negative Z value does not mean that the area is negative. In fact, area or probability can never be negative. So if you do find, when you're doing other calculations, that your area or your final answer is negative, you've made a mistake. So step 3, it's best to draw out the distribution to fully understand how to do step 3. And look at that nice distribution. Average is 100, standard deviation is 15, and we put this x value of 80. It's on the left side, it's below average, and it's right there. X equals 80. Now we have to always shade in part of the distribution, and we're going to shade in this because of that. It says less than 80. So we're shading everything over to the left side from 80. Students will always ask me, do we subtract the area from 0.5? Do we add it to 0.5? What do we do? How do we know? And the best answer is found by drawing it out. Because now we know that the answer, what the answer will be. We know that this, the full side on the left side, has an area of 0.5. We've calculated this middle area to be 4082, because the area corresponding from Appendix B, based on that Z value, is always from the middle outwards. It's always right in here, always from the middle outwards. Does not matter because we're going on the left end that it's negative. So this area is positive 4082. We want to know this section here, the shaded in section, so once again we are going to subtract. And we will get an answer of 0.0918. If you want, you can change that to a percentage. Either one is correct. 4 decimal places is preferred. Basically tells us that there is a 9.18% chance of randomly selecting an individual in the population and have his or her IQ less than 80.